Hello, in this video let's discuss third question of today's contest. You are given two integer arrays of size 2, D1, D2 and R1, R2. Two delivery drones are tasked with completing a specific number of deliveries. Drone I must deliver DI and D2, 1 should complete D1 and 2 should complete D2. Each delivery takes exactly 1 hour and only one drone can make a delivery at any given hour. Additionally, both drones require charging at specific intervals during which they cannot make deliveries. Drone I must recharge every RI hours, that is hours of multiple of RI. Return an integer denoting the minimum total time required to complete all the deliveries. And D is up to 1 in 9, D1, D2 are up to 1 in 9, and R1, R2 are up to 3 into 10 power 4. For example, let's take 3 1 and 2 3. The first drone can deliver at 135 and recharges multiple of 2, which are 2 and 4. And the second drone delivers at hour 2 and recharges delivered at time 3. So in this way the total deliveries can be done within 5 hours. So the answer is 5. So let's say we only have one drone. And what is the time it will take to deliver its D0 ones? So let's say we only have one drone. So D0 is 4 and R0 is 3. So what is the time it will take to deliver these number of orders for D0? So it can deliver at 1, 2, 4 and 5. It must recharge at 3. So it is simply 5. Without recharging, the answer will be simply D0 because at each hour it can complete. But because we have to recharge, and what are the number of multiples of R0 in D0? That is the extra number of time required because of charging. It is simply D0 minus 1 by R0 minus 1, which can be taken by examples. So for 4, there is only one which is multiple. So in this way, for a single drone, we can find the answer. We can find the time to deliver by recharging, which is very simply D0 plus this one. So now we have two drones and we have to find the least time to get the answer. So how can we do that? So first let's find the answer for 1 and 2 separately. So for drone 1, distance 1 is the minimum time taken, and for drone 2 it is distance 2. For example, let's assume T1 and T2. And now what is the final answer? So we have the answers for both separately, but we have to find the minimum time, right? So how can I do that? Is that simply D1 plus D2? No. Let's take an example. For example, it is D0 is 3, R0 is 2, D1 is 1 and R1 is 3. So now what is the time? So for drone 1 it is 5 because we discussed before. It is simply 3 plus 2 by 1, which is 5. And for this, only 1 is sufficient because after completing 1, no need to recharge again because all the deliveries were done. So for drone 1 it is 5, for drone 2 it is 1. And now looking both together, what will be the answer? So this is for first, this is for second one. So if we clearly observe, it is simply the maximum of D1 and D2, right? Because if the drone 1 is recharging at 2 and 4, drone 2 can be delivered at that time. Drone 2 can deliver at that time. And when drone 2 is recharging, drone 1 can deliver in that time. So we can utilize some recharging parts of both as recharging of other one. So it is from this we can say that it is max of D1 and D2 and not D1 plus D2 for sure, because it will take more time, but maximum will be surely less than sum of those both, right? So for now what we got, it is simply max of D1 and D2. But is that right always? Always no, because let's say what if recharge points of both are same? For example, 3 2 and 5 2. So if these are D0 D1 and R1 R0 R1, how can we find the answer? So for the first one, it will recharge at 2 and 4. It will deliver at 135, right? 135. And then coming to second one, even it is same. So 1 3 5 7 9. It will deliver at these places and recharge at 2 4 6 8. So now the maximum of these both will not be the answer, because at same time both have to recharge. So even when it is recharging, other cannot deliver. So answer is not always given. So the answer is not always max of these both, but in many cases this can be possible. But there can be many cases as well where this cannot be also possible. Then how to find the answer? So why the answer is simply D1 plus D1 minus 1 by R1 minus 1. So why is this case? So this is correct because this repeats every interval of R1, because it must deliver, it must recharge at every Rm multiple. So R1, 2 R1, 3 R1 and so on. So it is like a repeated pattern of some distance and R0, because this is R0, this is recharging at R0, and this is recharging at 2 R0, this is recharging at 3 R0 and so on. So this is like a periodic pattern, right? So because of periodic pattern, we just wrote that it is simply the total time without any recharges. And what is this? So R1 minus 1, it is simply the total number of multiples, and this is like a simple pattern. In a single repeated pattern, this is the count. So for single drone, it is repetitive. But what about two drones combinedly? So can we make the whole travel of drone 1 and drone 2 in a single way, like we done for this, right? So can we do that? Yes, can we do? And what is that? So if we clearly observe, what is the total distance, what are the total number of deliveries? So the total number of deliveries are d1 plus d2 combinedly, right? So d1 plus d2. And what is the net, we are seeing both with respect to only one, right? So now what we are assuming? We are assuming that there is a single drone which will do combinedly the deliveries of both d1 and d2, which is d1 plus d2. So there is a single drone now. So the total number of deliveries is sum. And what is the net R? What is the net recharge hour for this combined drone? It is simply LCM of these both, right? For example, let's say the drone 1 is recharging at 2, the drone 2 is recharging at 3. So uniquely, so this will recharge at 2, 4, 6, 8 and so on, and this will recharge at 3, 6, 9, 12 and so on, right? So what is the same point? What is the intersection of these both when we are assuming these both as together? It is simply LCM of these both, which is 6. So when we are thinking with respect to these as both, what is the recharge point? It is simply 6. So now it is same as a unit at a single drone. So the total deliveries are 5 and the recharge point is 6. And what is this 6 means that? So the netted drone will be recharging at 6, will recharge at 12, will recharge at 18 and so on. So in this way we are able to get a single perspective of both drones combinedly with respect to a unique one. And why is this correct? So this can be correct in the cases where maximum of d1 and maximum of distance 0 and distance 1 is not possible. And when is that possible? For example, this may be a case where both have same recharge hours. So when a single drone is recharging, the other is also recharging, so the other cannot deliver. In this way, the maximum is not the answer. In this way, we can find the answer by this way, by simply LCM. So hope you got this. Let's take an example also. So it is function of net distance, net number of deliveries, and LCM of this both. So let's take an example. So if 1322, D0 D1, R0 R1, and for this the answer is 1 individually, and for this the answer is 5. For this, let's assume, for 1 2 it is 1, and for 3 2 it is 5. So what is maximum of this both? It is 5. But we discussed that both these are equal, 2 2 are equal, so that will not give an answer, because maximum of this, what we will take, we'll assume that one will recharge at other and other will recharge when other is recharging, but that is not the case in this. So now what is the net answer? It is simply the total number of deliveries. So what are the total number of deliveries? It is 4. And what is the net effective recharge? It is 2, because LCM of this both is also 2, right? So what is the net time it will take? So it will deliver at 1 3 5 7 and recharge at 2 4 and 6. 2 4 and 6. And what is the net time? It is 7. So what is 7, right? So if we clearly observe, we are utilizing both, right? Because the total number of deliveries are 3. So the drone 0 can deliver here, drone 0 can deliver here, drone 0 can deliver here, drone 0 can recharge here, and drone 0 can recharge here, right? Or drone 1 can recharge here, and drone 0 can recharge here. As drone 1 recharged here, drone 1 will deliver here. So in this way we are able to make both correct, because we are able to make both d1 plus 2 deliveries, and also we are making sure that at combined multiple, For example, at 246, we are not delivering anything. We are using recharging both, or we are recharging only one, or we can recharge every drone, both the drone at this. But we are making sure that at 246 we are not going to deliver anything. So that is what we exactly want. So in this way, so only this is not the case, right? So only when R0 is equal to R1, this is not useful. Not like this. There may be a case where even they are unequal, but the number of things are unequal. So this gives an extra way to find the answer in a better way. So what will be the net answer? It is simply maximum of this one on maximum of this one. Sorry, maximum of this, comma this, comma this, where this is G1 plus G2 and the LCM. So hope you got this. So there can be a case where the new one is greater than sum of those both, can be equal to sum of those both, or can be less than sum of those both. So we are just using the new one so that it will give a new perspective to find an answer. So now we got 3 different answers, and now what will be the final answer? So it is maximum of all 3. Why maximum of all 3? Because the D1 time. So what is the D1 time? So the D1 time is the, at least it is the minimum time for drone 1 to complete its deliveries, right? And D2, what is D2? It is at least, so that is the minimum time for drone 2 to deliver all its deliveries. And coming to D3, and what is that? It is the least time to deliver both these combinedly when we are using LCM, right? So the answer must be greater than equal to all these. So with respect to perspective of D1, it must be greater than equal to D1. For 2, it must be greater than equal to, and when we are seeing combinedly, it must be greater than equal to that. So now what is the final answer? It is simply maximum of all these both, because we want an answer which is more than this, and more than this. So what is the thing that will be same for all, that it will be sufficient for all? It is simply maximum one. So now the answer is simply maximum of all 3. So we can think that why we simply not return D3, because in D3 we are trying to make, like we are trying to find the LCM and then we are trying to find the optimal answer, right? But this is not always the case, because what if we have something like this? What if we have something like this, right? So if we have 3, 1 and 2, 3, if we find LCM, it will take more time, because there we are not using one used by other. We are making both as different, and the only goal of making LCM is not to deliver at recharge points. But what if these are like this? So the maximum of D1, D2 will give the maximum answer for this. So no need of other thing. So simply we can take maximum of all these both to get the answer. Let's check the code. So this is the function. So what will the function return? The function will return the time for deliveries. So K is without the recharge, and this is the number of recharges. So now these are R0, R1, and now find the distance for only drone 1, only drone 2, and then find the answer for drone 3 combinedly, which is the total deliveries are D1 plus D2, and then this is the LCM, which is product by JCD, which is LCM, and then the answer is simply maximum of all these 3. So if you have any doubts, comment below. See you in the next video.